In the previous two videos of law of sines, we looked at what I consider to be the two simpler cases. They both give you two angles, so you can just find the third angle and use your formulas to find the remaining sides. Here, we're going to be taking a look at what happens if they give you two sides and a single angle, and this time the angle is not included. If it was included, you'd use law of cosines instead to solve the triangle. In this case, you actually have several different things that could happen. And I want to very briefly explain what I mean by that and why this is called the ambiguous case. Ambiguous meaning sort of uncertain, unclear, that sort of thing. If I'm given two sides and an angle that's not included, that means that my first side, for example, could be something like this. And let's say I'm given the angle here. Let's say I know what this angle measure is. But I do not know the length of this bottom side. So let's go ahead and say that that bottom side could extend anywhere out here that it wants to. Well, the idea now is if I'm given that last side length, then what might happen is that side length could be this side length here. Now that makes a nice little obtuse angle at the bottom here, and we'd say, okay, well, here's a triangle that we could have. If this was that second length that we had, this could be one triangle that we could end up with. But what if I pivot this side here? What if I brought it out here instead? If these two sides here, if these two lengths that I've just drawn were the same, then I could have one triangle that has those same measurements. It could have the same angle, the same first side, and the same second side as this other triangle I've drawn that looks more like this, that has this same angle, the same side here, and the same side length over here. I could have two triangles that have the same two sides and the same non-included angle, but one of them ended up being an obtuse triangle, and the other one ended up being an acute triangle. And so what we're going to realize is we need to be able to have some method to tell whether or not we're going to have two triangles, and we need to have some way of determining whether or not we have any triangles at all. And that seems kind of weird to say. One of the things that could happen with side-side angle is you may just not even have a triangle. You may have just one triangle, or you could have up to two triangles. So the idea is we're going to go and check certain values that might show up. When you're given a problem like this, you're going to be given an angle to look for. You're going to have some sine of theta to work with. So let's say, for example, that we had sine of A. Let's say this angle that you didn't know at the start was A. So we're saying that there's a missing angle here that pairs with one of these two sides. We know that in general, this should equal, let's assume the other side we were given was B. We know that these two things should exist. What's going to happen is, in order to start solving for A, big A, we're going to multiply both sides by little a. This is familiar from previous videos if you've kept up. And what we're going to see is that we can actually test whether or not we have one triangle or no triangle or two triangles, that sort of thing, by just evaluating this thing here. We know from discussions of the unit circle that our sine values, when we reach the top of the circle, this height up here, the largest the sine value can ever be is 1, because that's the highest point on the circle. If you end up with sine of A, or maybe I should even say sine of theta here, but we'll just use A since I chose that. If that A value, that sine of A, is greater than 1, this is going to tell you that you have no triangle. Or maybe you might even call it no solution. Because it's not possible. You cannot have a sine value of A be greater than 1. In fact, if you were to go to a calculator of some kind in degree mode, and you go in and say, or actually even in radian mode, take inverse sine of both sides here. You say A inverse sine of all this stuff. You're going to get an error message in your calculator. That's because it realizes that this number is going to be too large. Now, as a note, it is possible for sine of A to be equal to 1. This happens at the top of the unit circle. That happens at an angle of 90 degrees. This would tell you that the measure of angle A is 90 degrees, which tells me we have a single right triangle to work with. And that's good news. We almost hope that that happens, because then you know for a fact, without a doubt, that you have a single triangle that you could get out of this problem. The final circumstance is the one that you're going to want to see more work on, and we'll do examples of these in future videos. The final example is if your sine value of A or theta, whatever you're working with, is between 0 and 1. Now, it's not going to be equal to 0 here, because to be equal to 0 would be to have an angle of 0. And we know that in a triangle, one of your angles is not going to be equal to 0. That doesn't make any sense. So if sine falls between 0 and 1, it's going to turn out that you will have two possible triangles. And under these circumstances, you could have an acute, I'll say and or an obtuse triangle here. The idea being that you could have an acute triangle, or you could have both of these guys. Some problems may only ask for the obtuse triangle. You see sometimes problems will say, well, this angle is an obtuse angle. And so that's something to watch out for as well. But these are the conditions you're going to check, and we'll see this in our examples soon in another video. But the idea again being that you could have these two different triangles that work out here, and that you can test it by just saying, well, look, they gave me a matching pair of angle and side. They gave me one of the sides, so I can test my sine value. I can test whatever this number is. So this number is really the one we're looking at here. If this number is bigger than 1, no triangle. If this number is equal to 1, you have a right triangle. And if this number is between 0 and 1, there's going to be a way to test and see what combination of things you have to work with.